All right, section 5.5, solving exponential functions. So this is the section where we're actually going to take all of the stuff that we've learned in the previous sections and apply those rules so that we can actually turn them into equations and solve for x or whatever variable that we have. When you're solving all of these, there's going to be two methods that we're going to look at. The first method is going to be using something called the base exponent property. That says that if you have a to the x is equal to a to the y, that means that x is equal to y. We're assuming a is the same value here. We're also going to assume that a is greater than 0 and a is not equal to 1. So it only works for positive values and it doesn't work for the value of 1. The second method that we're going to learn is we're going to change the form. I'm going to change the form from exponential to logarithmic form, or from logarithmic form back into exponential form. And just as a review, if you have a to the x is equal to y, you can change that into log base a of y is equal to x. And vice versa, if you have a logarithm here, here's your base, here's your argument, here's your exponent, you can change that back into exponential form. Many of the problems you can solve using either method. Some are going to be easier using one method over the other. I tend to use this one quite a bit, although this one is equally as good. Let's do some examples. Now let's say we have 3 to the x is equal to 20. Here I'm just going to change the form. So this is going to be log base 3 of 20 is equal to x. So I've effectively solved it for a single variable. Now I'd actually like to know what this is. So we can use our change of base formula. And we can say that this is the natural log of 20 over the natural log of 3 is equal to x. Grab our handy calculator, and we're going to do the natural log of 20, close parenthesis, divide by natural log of 3. Press enter, and we're going to get 2.73. Now all of these decimals will go on forever and not repeat any pattern because they're logarithms and exponents. Another example would be 2 to the 3x minus 7 is equal to 32. Now I'll show you how to solve this using both ways. Because I know my exponents, I know that 32 is 2 to the 5th. So now I can just cross off the bases and I have 3x minus 7 is equal to 5. 3x is equal to 12. And then x is equal to 4. So this is using our base exponent property that we had earlier. Or if that's not working for you, you can always change the form. You can change this into log base 2 of 32 is equal to 3x minus 7. Put this into your calculator as the natural log of 32 over the natural log of 2 is equal to 3x minus 7. And you can do this because maybe you don't know your exponents. So we're going to do natural log of 32 divided by natural log of 2, we're going to get 5. And then we're exactly back to where we were right here. Solve it, and you get x is equal to 4. Let's look at a different example. Let's say we have 100 e 0.08 t is equal to 2500. So now we're starting to get into problems that are going to look more like applications of things that we might actually do. If you have a number out here, divide it out first. That's always going to be your first order of business. We're going to get e to the 0.08t is equal to 25. This isn't e to anything, so I'm going to change the form here. So I'm going to change this into log base e of 25 is equal to 0.08 t. Log base e is the natural log. But I'm going to also divide both sides by 0.08. So now it's just a calculator problem where I'm going to do a natural log of 25 divided by 0.08. I'm going to get 40.8.